Now we want to show you the cable connection board. On this board, 5 sections have to be distinguished. Section A contains the inverter communication port, including CAN and RS485 and the enable line. Section B contains the dip switch for setting communication termination resistor. Section C contains the dip switch for setting primary secondary packs. Section D is only dedicated for the use of battery section monitoring. This is a tool to check the battery status. So do not connect the internal communication port on Section D. On Section E you have the battery power port including positive, negative pole and grounding. Now we are coming to the different steps of the cable connections. For Section A, at first please connect the enable ground wire with terminal 2. Then connect the enable 12 volt positive line to terminal 1. Please select the method that matches the inverter communication method in the part marked. If the inverter uses the RS485 protocol, then please connect the lines to terminals 3 and 4. If the inverter uses the CAN protocol, then connect the CAN lines to terminal 5 and 6. If the inverter has separated port for parallel expansion like its SMA inverter, power and communication cable is connected like as a single battery pack based on the inverter installation manual. Then do not follow this instruction. At Section B, please lower the dip switch, that is the communication terminal resistor, all downwards for single pack. When you install 2 packs, please refer to the appendix about setting for communication terminal resistor. What happens if Section B is set incorrectly? The battery itself cannot determine whether it is number 1 or number 2. Consequently, the battery does not start operation. Furthermore, the inverter cannot recognize the battery. And finally, the battery cannot determine whether it is CAN or RS485. The picture on the left side shows you the right positions of the dip switches. Raise all dip switches upward when you want to use as a primary pack. And also when you want to use as a secondary pack, lower the switch on the right side only when viewed from the front. In Section E, you have to connect the ground wire to terminal 2, then connect the negative line of the power cable to terminal 3, and connect the positive line of the power cable to terminal 1. The first picture on the left side shows Section B, the dip switch for setting communication termination resistor. When the installer opens the box of the battery control unit, Section B is at on condition by default. Then the installer can choose the on condition for the single battery use case. If the installer wants to run a parallel double battery pack, the primary set has to be on switched and secondary has to be set off switched. The second picture on the left side shows Section C, dip switch for setting primary secondary packs. When the installer opens the box of the battery control unit, Section B is set at on by default. Then the installer sets the on condition for setting the single battery. If installer wants to set parallel double battery packs, the primary pack sets the primary condition and secondary the secondary condition. The following chart gives you an overview of the definitions and requests of the different type of cables. First of all, there are stripping requests to the different kind of cables, and it's 15 millimeters for the power terminal cable and 10 millimeters for the communication terminal cable. The power cables should have a maximal cable length of 10 meters. They should have an insulation of DC 600 volt. The maximal cable length for the communication terminal cables is 10 meters. This chart is also given in the installation manual. The following chart shows you the state of the battery indicated by the different 4 LEDs which are at the front of the battery packs. Under normal conditions, the LED 1 is always green and on. LED number 2 indicates if the battery is charging or not charging. The LED number 3 shows you if a process of discharging is occurring. The LED 4 is meant to show up a fault which is happening. By means of this matrix, you can see what state of the battery is happening in all combinations of the 4 LEDs.